I want you to imagine, just for a second, that you are observing something incredibly small and, subtle. Let's say you're looking into an aquarium.
Right, there's a standard fish tank in your living room.
Exactly. You are watching the fish sort of tracing their movements through the water, and you notice two of them interacting in this very specific, slightly unusual way.
Which is pretty easy to miss if you aren't paying attention.
Oh, for sure. Most of us might just smile, tap the glass, and walk away. But imagine deciding to sit down and meticulously document that exact fleeting moment as part 229 of a lifelong, highly structured logging project.
It creates a really striking contrast, I think. You are taking the fluid, almost entirely unpredictable nature of animal behavior and, well, dropping it straight into a rigid, numbered filing system.
The organic world meets the database.
Yeah, exactly.
Which is the entire foundation of today's deep dive. So welcome in. We have a really fascinating stack of notes to go through today.
We really do. These logs are entirely unique because they just completely blur the line between nature and analytical data tracking.
And our focus today is entirely on the content of these meticulous observations.
Right, because the source material operates on two totally different frequencies simultaneously. On one hand, you have the quiet, subtle observations of an aquarium or a garden.
Like tracking a fish swimming.
Yeah. And running parallel to that, you have the hyperstructured, logical tracking of complex functional programming languages and software architecture.
It's wild. So our mission today is to decode all of it. We are going to look at the surprisingly nuanced indicators of angelfish bonding, uncover the hard, often blunt physical realities of animal husbandry, and ultimately explore what a massive, sequentially numbered collection of tracked hobbies tells us about the intersection of a highly analytical mind and the natural world. Okay, let's unpack this.
Let's start right at the water's edge, I'd say. The core biological observation in this specific log entry centers around a pair of angelfish.
Right, just two regular angelfish.
Yeah. The notes detail an observer prepping for some upcoming breeding projects, picking up supplies, and happening to stumble upon these two fish. And based on past experience, the assumption is made almost immediately that a bond has formed between them.
Which prompts the immediate question in the logs, how can we tell if these two have actually bonded?
Right, they want proof.
Exactly. It shifts the text from a casual assumption right into seeking physical evidence, and the evidence they focus on is all about aquarium geography.
Spatial awareness in a tank is huge.
It really is. Comparing them to the rest of the angelfish in the tank, the most obvious sign is that these two have claimed a very specific spot, completely isolated and far away from the rest of the group.
Because, in an enclosed environment like an aquarium, space is the ultimate premium. When two fish decide to intentionally remove themselves from the traffic of the main school, it's a significant behavioral shift.
They are staking a claim.
Oh, absolutely.
It makes me think of like two high school sweethearts walking into a crowded diner. They bypass all their friends at the big tables in the center and just immediately claim the remote, sticky corner booth all the way in the back just to get away from the crowd. It is classic territorial isolation.
That is a perfect analogy. And the notes actually go even further into this territorial aspect, mentioning that while they didn't actually see the bonded pair chasing any other fish off, it is safe to assume they would if necessary.
Right.
The only reason a chase wasn't observed was simply that no other tank mates happened to wander near that specific corner at the time.
I do have to push back on the next piece of evidence, though.
Okay.
Yeah, the logs mention that with angelfish, you usually notice the pair swimming in parallel, which is sort of the precursor to a mating dance ritual.
Yes, that's true.
But, in a confined glass box, couldn't swimming parallel just be a coincidence of traffic? Like two cars ending up in adjacent lanes on the highway for a few miles?
I see what you're saying.
Because I imagine that hovering in one place for a fish requires continuous micro-adjustments. They aren't just drifting, they're actively burning calories to hold that perimeter right.
What's fascinating here is that you've hit on the exact biological mechanism at play.
Wait, really?
Yeah. In the context of cichlids, which angelfish are, these subtle behavioral shifts are incredibly demanding. Angelfish are laterally compressed.
Meaning they are flat, basically.
Right. Their bodies are built for weaving through dense Amazonian plant life, not hovering static in open water. So to break from the school, hold a specific static perimeter in a corner, and continuously mirror the movements of another fish requires active cognitive effort and a massive caloric burn.
Oh, wow. So the parallel swimming is essentially a physical fitness test.
Precisely.
They are proving to each other that they have the stamina to hold a territory.
It is a synchronized display of alignment. Sea slids are known for intense biparental care.
Meaning both parents raise the babies.
Exactly. Both the male and the female are going to be responsible for guarding the eggs and eventually the fry against predators. That parallel swimming is their biology telling them to secure a safe drop zone, test their partner's reflexes, and prepare for the massive energy drain of raising the next generation.
So it's not a coincidence at all.
No, it is entirely deliberate.
They are clearing the diner booth, syncing up, and getting ready for the big romantic leap, which naturally brings us to the next logical step in the logs.
Right, the breeding.
Yeah, we've established they are bonded, they are biologically prepped, they are burning the calories to hold their corner. The log then poses the obvious question, should we breed angelfish again?
Which prompts a drastic shift in the tone of the documentation.
Here's where it gets really interesting. Because the answer to that deeply romantic, biologically profound buildup is a blunt, immediate, not really.
Just a clean, pragmatic rejection of the entire process they just spent so much time observing.
It's such a strangely detached footnote. You just spent all this time clinically observing their courtship, breaking down the mechanics of their parallel swimming, and then you just dismiss the idea of actually facilitating it.
Yeah, they just shut it down.
It's a jarring pivot away from the romance of nature straight into the cold, logistical reality of tank management.
The pragmatism is striking, for sure, but it's driven by biological necessity. The notes lay out the exact physical constraint driving this decision. It really comes down to water volume.
The size of the tank.
Right. They state very clearly that they lack the large aquarium tank capacity needed to breed this specific species properly.
Nature might be finding a way in the corner of that tank, but biology has a hard wall, and that wall is physics.
Yes, exactly.
Specifically the chemistry of the water. Because if we are talking about breeding angelfish, a successful spawn doesn't mean you get 2 or 3 babies. You can get hundreds of fry all at once.
Hundreds of highly active, constantly eating, constantly excreting tiny fish. And this is where the mechanics of responsible animal husbandry come into play. If we connect this to the bigger picture, the limitation isn't just about swimming space, it's about the nitrogen cycle.
Right, because fish excrete ammonia through their gills and waste. And in a healthy tank, you have colonies of beneficial bacteria living in the filter that consume that toxic ammonia and convert it into nitrites, and then into relatively harmless nitrite.
The biological filtration system.
Exactly.
And that bacteria colony grows or shrinks based on the steady-state biological load of the tank.
So it adapts.
It does, but slowly. If you suddenly introduce 300 growing fry into a tank with a water volume that is too small, the bioload skyrockets overnight. The established bacterial colony simply cannot scale fast enough to process the sudden spike in waste.
So the ammonia levels spike, the water turns toxic, and the tank crashes.
It is often called bioload shock. The water might look crystal clear to the naked eye, but chemically it becomes lethal. It is incredibly easy for hobbyists to get caught up in the excitement of a spawn.
I can imagine.
Yeah, it feels like a massive success, like you've engineered an environment so perfect that life is flourishing. You start feeling like an architect of nature.
But true discipline is recognizing the invisible limits of your infrastructure.
Exactly.
The restraint shown in these notes, the ability to look at a natural process, understand the biological mechanics of it, but consciously choose not to facilitate it because the water volume won't support the math. That is the mark of a highly analytical caretaker.
They are managing the environment, not just reacting to it. They understand that a tank is a closed loop, and if you exceed the parameters of that loop, the system fails.
And they manage it with a heavy dose of personal preference, too, because right after citing the tank capacity and the logistical hurdles, the author just unabashedly adds, furthermore, I'm not that keen on angelfish anyway.
I love that line. It adds a layer of mundane reality to the whole entry.
It really does. You spend all this effort analyzing their micro adjustments and territorial habits, and then casually drop that you don't even particularly like the species.
Yeah.
It is a very calculated attachment. But when you zoom out and look at the larger context of these source logs, that blunt clinical logic suddenly makes total sense.
Oh, definitely.
Yeah.
The angelfish observation is just one tiny data point in a staggering ecosystem of tracking. The sheer scale of the numbering system really reveals the underlying mindset.
Let's look at those numbers, because the scope is massive.
It's huge.
The specific angelfish entry we were just discussing is titled Notes on Fishkeeping Part 229, But that barely scratches the surface. We are also looking at notes on gardening part 861.
861.
861 entries dedicated entirely to the garden.
And you have these deeply organic logs running side by side. There are betta spawn logs, detailed evaluations of hydroponic setups. We see entries about growing white sesame and checking on the progress of Brazilian spinach.
Which sounds delicious, by the way.
Right, and all of this sits in the exact same chronological feed as incredibly dense, highly technical analytical logs.
Right next to the Brazilian spinach, you have notes on Haskell programming, up to part 104.
Which is a massive jump in topic.
It really is. And for listeners who might not be familiar, Haskell isn't just any programming language. It is a purely functional programming language. It is heavily mathematical, deeply abstract, and relies on strict rules.
Very rigid.
Yeah, and these logs document parsing variables and refactoring code right alongside the daily water parameters of the fish tank.
The technical logs are vast, really. They cover Elixir, Erlang, Rust, Go, Python, artificial intelligence typesetting. There is even a series called Notes on Dieting, which includes daily body weight tracking up to part 111.
So what does this all mean? Because the tension here is fascinating. Think about what a functional programming language like Haskell actually does. In Haskell, you have what are called pure functions and immutable variables. If you define a variable as having a certain value, it holds that value forever. It cannot be mutated.
Right.
A pure function will always return the exact same output if you give it the same input. There are no side effects.
It is an environment of absolute, mathematically provable predictability. The code does exactly what it is written to do, isolated from outside interference.
But biology is nothing but side effects. A fish tank or a patch of Brazilian spinach is an entirely mutable system. The soil pH changes every time it rains.
Exactly.
The bioload of the aquarium shifts every time a fish eats. You are constantly battling temperature swings, decomposing matter, unexpected algae blooms. It is inherent chaos.
This raises an important question about the methodology we use to process the world around us. What we are seeing in these logs is an attempt to apply the state management logic of software architecture to the highly mutable organic world of the living room.
It is treating dirt and water like code.
Yes.
If tank capacity equals X and biological load equals Y, then breeding equals false. They are trying to create version control for real life.
And by assigning a part number, like part 229, part 861, the observer is inherently acknowledging that today's observation is built upon yesterday's data and will inform tomorrow's action.
It's all connected.
It suggests a worldview that sees literally everything, biological life, physical health, software development, as a series of continuous, interrelated projects.
And the frequency of the data collection proves how ingrained this philosophy is. The archives go back to 2011. In 2024 alone, there were 732 log entries published.
Wow.
Yeah, in 2025, another 730 entries. That is an average of 2 documented, categorized, numbered observations every single day, year after year.
It strips away the illusion that gardening or fish keeping is just magic or luck.
Well,
When you log that much data, you stop seeing a garden as a mysterious entity that either grows or dies based on the whims of nature.
you start seeing it as a system of inputs and outputs.
Exactly. Sunlight, water volume, soil nutrients, these are just variables. If you track the variables closely enough, the system can be understood and optimized.
It acts as an anchor, ensuring that personal whims don't override practical limitations, like we saw with the angelfish.
Right, the hard no.
Yeah, the romance of the mating dance didn't override the hard data of the tank's water volume. The data keeps the observer grounded in physical reality, preventing them from making an emotional decision that would ultimately crash the ecosystem.
It is a remarkable level of discipline, honestly. Most people interact with their hobbies sporadically, they engage when they feel inspired, and they drift away when they get busy.
I know I do.
Yeah, we all do. But a sequential logging system demands daily presence. It forces you to look closely at the micro-adjustments happening in your environment, whether that's the subtle parallel swimming of a cichlid or the slight yellowing of a spinach leaf.
We really went on quite a journey with this one. We started by looking into a quiet, isolated corner of an aquarium, watching 2 angelfish sync up their swimming to test their physical fitness and claim a territory.
And from that one tiny documented moment, we zoomed out to reveal a massive, structured tracking system spanning over a decade, hundreds of life disciplines, and thousands of entries.
We watched the chaos of biology collide with the rigid, immutable logic of functional programming.
The through line is the power of sustained observation. Whether you are parsing code or measuring water chemistry, the act of paying attention changes your relationship to the subject.
It really does. And it makes me want to turn this around and ask you, the listener, a question. How do you manage your own interests and environments?
Are you the kind of person who meticulously tracks your progress?
Right. Do you have complex spreadsheets for your garden yields or a daily log for your workouts that stretches into the hundreds? Or are you the type who just tosses some seeds in the dirt, throws some fish in a tank, wings it, and hopes for the best?
Both approaches have their merits, but the contrast in methodologies dictates an entirely different understanding of the world around us.
Which leaves us with this final thought to ponder. If we start meticulously logging every natural behavior in our lives, from the daily habits of our pets to the exact growth parameters of the plants on our windowsill, does that intense, numbered scrutiny make us feel more intimately connected to the chaotic beauty of nature? Or, by quantifying every micro-adjustment and water parameter, do we risk turning the living, breathing world around us into just another dataset waiting to be parsed? The next time you find yourself tapping on the glass of a fish tank, ask yourself, are you just watching, or are you ready to start? Part 1.